So this C program implements a hanging code of which is an error detection and correction code used to encode the 4 data bits into 7 data bits by adding 3 parity bits. The program performs the following tasks. First is that it encodes the 4 bit of data into 7 bit Hamming code. Second is simulates a transmission where errors might occur, detects and corrects error based on the syndrome values. Fourth is recovers the original data from the corrected code. So let's break down the key components of the code, and I'll provide an example of the output to help you understand better. See, first the sequence what I've taken is just first to generate the matrix. The generator matrix G4, 6, it's like 7 columns and 4 rows, is used to encode the 4-bit data into 7-bit code. Each row of the matrix corresponds to one of the data bits, and the column represents how each data bit can contribute to the 7-bit code word. Second is the parity check matrix. The parity check matrix is that h of 3, 7 is used to calculate the syndrome of the received code. The syndrome is used to detect the errors and locate whose those errors are. Okay. And the syndrome table. The syndrome table 8 maps the syndrome value, a 3-bit binary number, to the bit position where an error may have occurred. A syndrome value of 0 indicates no error, while any other value indicates an error in the one of the 7th bit. Main functions what I've used is as the encode. The function encodes the input 4-bit data into 7-bit Hamming code using the generator matrix. It performs the XOR operation. XOR operation is basically when a 0 for 0 and 1 your output is 1. It performs an XOR operation across the data bits and the corresponding bits of the generator matrix to produce the encoded code. Second is computer syndrome. This function calculates the syndrome based on the received 7-bit code and the parity check matrix hits. The syndrome is calculated by multiplying the received code with each row of the matrix performing the XOR operations. See, binary to decimal converts 3-bit syndrome into decimal equivalent to help look up the error position in the syndrome table. Print bits, helper function that prints binary data like encode data, syndrome, etc. And the fifth stage is that main logic. What I've used here is first input data. The program prompts the user to enter a 4-bit sequence. Second is encode. The data is encoded using the encode function, producing a 7-bit encoded code. Third is transmission simulation. The user is asked to enter the received 7 bits which may contain an error. This simulates a real world scenario where a data might get corrupted during the transmission. Error detection and correction. The program computes the syndrome using the computer syndrome function. Based on the syndrome, it checks if any error occurred, and if so, it corrects the error by flipping the erroneous bit. See, the output. The program displays the syndrome, error position, the corrected 7-bit code, and the original recovered 7-bit code. So let's enter the data here. Run it once again. Sorry.